All right, we are live, I think. So, yeah, let me check if this works. Uh, just for context, it's just gonna be a chill stream. I'm just gonna go through the Netflix recommender system, like go through the paper. Looked like a pretty interesting paper of how they like basically how does Netflix work behind the hood? How does their recommender system look like? How are they recommending movies to you? Uh, that's what we're gonna try to understand in this one. All right, so I'll just get through it. By the way, I'm trying out this new one. Zotero is was recommended to me and recommended, and hopefully it is like I'm just trying it out now, but it seems to be pretty good. You can sync it and basically like stores all of the different stuff that you're all the papers you're looking at and so on. So that seems pretty nice. Yeah, no one in the chat so far, but or yeah. All right, I'll just go through this. So the Netflix recommender system, algorithms, business value, and innovation. So I don't know which year this is from. Okay, 2015. So, but you know, Netflix has been around for such a long time that probably they like the system is pretty dialed in, right? I don't know. I mean, the Netflix competition was prior like 2009 or something. So imagine working on that recommender system for 6 years after, and it's pretty much the same thing, right? So yeah. So yeah, let me check if there's. All right, I don't know if this is a bad time to stream or not. I just kind of put it on. I'm gonna stream for like an hour, and then I have something else I need to do. So try to understand this in an hour. All right, this article, it's not a paper. Okay, so it's an article discussing the various algorithms that make up the Netflix recommender system and describes its business purpose, describe the role of search, related algorithms. We also explain the motivations behind and review the approach that we use to improve the recommendation algorithms, combining A/B testing and focus on improving member retention and medium-term engagement. All right, so let's just, first of all, as I always like to do with papers, I like to just skim it. So we want to get a rough idea of like what are they even talking about in this paper. I have somewhat of an idea. I think what they're trying to focus or like basically I skimmed this a long time ago and was mostly about uh, a lot of recommender system for various things. So that's what I'm hoping to get some insight into, but we'll check it. So introduction, they're talking about storytelling, which is, you know, a good, if you imagine like the amount of stories are told through movies, and Netflix is basically the carrier of these movies, right? So they do have, I mean, they do have a pretty important job, I would say. Okay, so here I've just tried this out, I think. Oh, okay, so I guess I've looked at this one a long time ago, maybe. I'm not sure. Okay, I don't know. Anyways, the Netflix recommender system, personalized video ranker. Okay, so just an overview, I guess, here uh, of the recommender system, and then personalized video ranker. By the way, like I don't know honestly if I think Netflix recommendations are that good. Uh, well, I mean, like obviously they're good. They must have like they've used metrics to show that, you know, obviously it is probably the best you can imagine. I'm surprised like nobody's in the chat. Okay. All right. So, anyways, hopefully this is live. Uh, Otherwise, I'll just talk to myself, I guess. Yeah, so like the recommender system that they have, I don't know if I think that it's that good because basically, right, if you have that many videos, you just get overwhelmed. I would kind of more like to have few ones that are really good for me, but I don't know, maybe that's not possible. I just spend a lot of time on like Netflix, like what movies to watch, and yeah, I don't think it's that great. But yeah, that I don't know the stuff behind it, so hopefully we'll learn about that. Okay, so what did they say? Personalized video ranker. They have rows on each homepage. Okay, so then here the videos in a given row typically come from a single algorithm. Genre rows such as suspenseful movies are driven by a personalized video ranker. All right, top N video ranker. Uh, so they have one that produces the recommendations in the top picks row. Okay. Actually, I haven't thought about I wonder what rows goes where on the Netflix because there's a lot of things they have to solve here. Like how, what order should things be in? Basically, when it comes to rows, how many should you, how should you select the ones for each row? And I guess even that might be personalized. I'm not sure. Yeah, I definitely seen the trending now. Continue watching. Video to video similarity because you watched. Yeah, that's some type of similarity. Checker page generation, row selection and ranking. All right, together these algorithms make up the complete Netflix recommender system, and this is very similar to today, right? I don't know how much the Netflix recommender system has changed over these years, but yeah. All right, for example, evident. Yeah, we don't have to. Actually, I don't know what to talk about here. Together, these algorithms, yeah. For example, evidence algorithms decide whether to uh, won an Oscar. Okay, so there's another algorithm that decides that. Then you also have search. So because members also often search for videos or genres that are not in our catalog, even search turns into a recommendation problem. So like when you search for a for a movie, you get recommendations as well on like similar movies that you would like to watch because they don't have that one. So that is itself a recommender system. Like it's pretty insane. I don't know if there's something wrong with this chat. I'll check it. All right. Yeah, there was something wrong, I think. Now I can see the chat. All right, what's going on, guys? Aditya, uh, could this be used to reverse engineer someone's customer data? Uh, I don't know. Good question. All right. Search. Basically, there's a million recommender system is like my summary of just skimming through this. But it's interesting to read more detail maybe of how they've actually done this. So business value. This is like the interesting thing as well, where it might be the case, right? This is like my fundamental question about Netflix recommender system too, is it might be the case that the recommender system that they have drive the most for like revenue and watch time and those kinds of things, but is it the most, I don't know what the word is for it, like is it the most valuable as a customer? Do you get the sense that you are watching the best movies for you after watching it? And that doesn't mean that you have to watch a lot. So this is generally like the conflict, I would say, for recommender systems, right? But I'm curious here too, like what they're. Yeah, okay. So our recommender system helps us win moments of truth when a member starts a session, and we help that member find something engaging within a few seconds, preventing abandonment of our service for an alternative entertainment option. Yeah, like is this like I don't know. I don't know if that's, maybe that's true for like general, but for me, I generally spend actually a lot of time of choosing which movie I'm gonna watch. It's very early that I just like put something on. Uh, right, so this is effective catalog size. Okay, so if you compare personalized to popular ones, video score ranks, take rate. Okay, we think that the combined effect of personalization and recommendation save us more than 1 billion per year. Curious about the word save here. Uh, and then they talk about improving our algorithms. Okay, and then they go talking about choosing metrics for evaluation. So they talk about all, so basically like they're all the recommender system, and then the business proposition, the value that they bring, and then the metrics. So how do they compare and iterate? And it seems like they focus on retention data or retention delta. Sorry. Nuances of A/B testing, test audience, and then also offline experience. So that's the one thing that I'm interested in. How do you evaluate? Do you evaluate based on uh, A/B testing mostly? It seems like a lot of companies do A/B testing because that is sort of the real test, but offline experiments are still useful. So, like, what's the trade-off there, or how much should you spend on offline evaluation and then A/B testing? Estimating word of mouth effects. Okay. There's also like a bunch of biases, right? For recommender system, you have, position bias. You also have biases when it comes to, uh, yeah, like the recommendations themselves are going to drive which movies people watch, which itself is going to get back to the recommender system to, like the impact that the recommender system of Netflix has on which movies people like to watch is, really big in itself. So there's interesting biases there in recommender systems. All right, so key open problems, better experimentation protocols. Wow, this is a long paper. I'm not gonna have time to go through all this in this time, but all right, all right. So let's. I think probably we want to know about this first. Maybe we can skip the introduction. All right, so we give an overview of the various algorithms in section 2, discuss their business value in section 3, evaluation stuff in section 4, some open problems in 5, and conclusions in section 6. Yeah, so yeah, like the problem in itself is pretty self-explanatory, I would say. Historically, the Netflix recommendation problem has been thought of as equivalent to the problem of predicting the number of stars that a person would rate a video after watching it on a scale of 1 to 5. We indeed relied on such an algorithm heavily when our main business was shipping DVDs by mail, partly because in that context, a star rating was the main feedback that we received that a member had actually watched the video. We even organized a competition aimed at improving the accuracy of the rating prediction, resulting in algorithms that we use in production to predict rate to this day. So that's actually that is what we read in the last stream 2 days ago, I think. So interesting to follow up on this as well. Now we stream the content. We have vast amounts of data that describe what each Netflix member watches. So first of all, like what they mention here is it right that the explicit feedback that they get from the ratings have downgraded in importance in comparison to maybe the implicit feedback, which I guess makes sense. If the reason, yeah, okay. I mean, it makes sense from like just the amount of feedback they get in comparison. The implicit ones are much larger in amounts. All right, so now we stream the content. We have vast amounts of data that describe what each Netflix member watches, how each member watches, the device, the time of day, day of week, intensity of watching, the place in our product in which each video was discovered, and even the recommendations that were shown but not played in each session. These data and our resulting experiences improving the Netflix product have taught us that there are much better ways to help people find videos to watch than focusing only on those with a high predicted star rating. Okay, so there are much better ways to help people find videos to watch than focusing only on those. So, I mean, they still have the rating, right? Maybe it's just like for historical reasons, maybe, but maybe it's the case that the implicit signals are enough. They don't need the explicit signals anymore. Yeah, that's interesting. Now, a recommender system consists of a variety of algorithms that collectively define the Netflix experience. So the personalized video ranker. There are typically about 40 rows on each homepage, depending on the capabilities of the device, and up to 75 videos per row. Okay, I wonder how they determined the 75 number. Like, I don't know. Maybe it's like a computational thing, or it's just that once you give more than that, it just doesn't have an effect. Maybe I'm not sure. All right, so the videos in a given row typically come from a single algorithm. So they have one algorithm for each row. So they basically have 40 different algorithms that give you recommendations. I mean, that seems like so much, right? It's like over-engineered, I would say. Genre rows such as suspenseful movies are driven by our personalized video ranker algorithm. Top end video ranker. We also have a top end video ranker that produces the recommendations in the top picks row shown on the right of figure 1. The goal of this algorithm is to find the best few personalized recommendations in the entire catalog for each member. Okay. I'm a bit confused now. Wait, let's see. So each typically comes from a single algorithm. Genres such as suspenseful movies are driven by a personal video ranker. As its name suggests, this algorithm orders the entire catalog of videos or subsets selected by genre or other filtering for each member profile in a personalized way. The resulting ordering is used to select the order of the videos in genre and other rows. Okay, so they have like one meta type of algorithm, like the video which gives you the row ordering maybe. Is that true? The resulting ordering is used to select the order of the videos in genre and other rows, and it is the reason why the same genre row shown to different members often has completely different videos. Okay, no, I think I'm misinterpreting this. This is just, I think they're just explaining it at a high level here. It orders the personalized video ranker orders the movies for a specific row, so it just reorders them in the correct order for maybe, yeah, as they say here, like suspenseful movies. They have a top end video ranker that produces the recommendations in the top picks few shown on the right of figure 1. The goal of this algorithm is to find the best few personalized recommendation in the entire catalog for each member. Yeah, okay, so like the PVR one, right? It takes a specific one and it reorders them in a specific ranking. The top end video ranker uses the entire catalog of movies, and I guess, you know, they use a candidate generator to subset, and then they use some type of ranker on top, maybe the PVR one. So accordingly, our top end ranker is optimized in the value using metrics and algorithm that look only at the head of the catalog ranking that the algorithm produces rather than at the rankings for the entire catalog. Yeah, I mean, that makes sense. Otherwise, the top end ranker and PVR share similar attributes. For example, combining personalization with popularity and identifying and incorporating viewing trends over different time windows. Okay, so yeah, what is this one called? Like when you look at Netflix, is this like the For You part, I guess, or something? All right, and then they have a trending now, shorter term temporal trends. So this is one thing that's interesting to take into consider for, like, especially for movies, right? Because there are definitely some temporal trends in movies where, you know, something is released, everyone watches it right now, and you want to, like, there's a social effect. You want to keep up to date with what people are watching, right? So that makes sense. All right, so there are two types of trends that this ranker identifies: those that repeat every several months. Oh, okay, that's interesting. So like romantic movies during Valentine's Day, or, you know, Christmas or stuff like that. And then you have the continue watching. That's interesting. Like you have, uh, do they have like a video ranker for the continue watching, continue watching ranker? Wow, I wonder like if it feels over engineered is like my spontaneous feeling. Uh, Maybe it is this complicated. Like you would maybe need this for optimal, but yeah, that's a lot of different stuff to maintain, a lot of different stuff to build, and just, yeah, interesting. All right, video to video similarity. You have a similarity algorithm. Um, yeah, because you watch something, it checks, you know, some type of similarity metric, which ones are most similar. Page generation, row selection, and ranking. All right, so what is this one? This is the one I was talking about. Like you need like a meta recommender for like what row should be in what order. Um, so the videos chosen for each row represent our estimate of the best choices of videos. Let's see. All right, but most members have different moods from session to sessions, and many accounts shared by more than one member of a household. By offering a diverse selection of rows, we hope to make it easy for members to skip videos that would be good choices for a different time, occasion, or member of the household, and could quickly identify something immediately relevant. Okay, the page generation algorithm uses the output of all the algorithms already described to construct every single page of recommendation, taking into account the relevance of each row to the member as well as the diversity of the page. A typical member has tens of thousands of rows that could go on one's homepage, making it challenges to manage the computations required to evaluate them. For this reason, before 2015, we used a rule-based approach that would define what type of row, e.g. genre row, because you watched row, popular row, would go in each vertical position of the page. This page layout was used to construct all homepage for all members. Today, we have a fully personalized and mathematical algorithm that can select and order rows from a large pool of candidates to create an ordering optimized for relevance and diversity. So I guess like they would specify how the page should look like, what type of rows you should have, a rule-based system, and then now they just completely automate it. I'm just curious. One thing is, I wonder if they have worked on, like, my immediate feeling just looking at this is that you have so many different components, and it's probably good in the way that every team can work on this in parallel. And even if you look at, Tesla, like they had this, I don't know what they call it, Hydra Net or something, I think, or I don't remember. Like they would basically have for all of these different tasks, they would have one neural network that shared the same backbone. But the issue is, if you have some team training on one specific thing, maybe they are competing for the same neural network resources. So what they eventually did is that they had basically a neural network for each specific task. So they've moved away from having one network that can do everything and have many that has been my understanding at least. So I don't know if Netflix has moved towards having a single one that does all of the recommendations. It seems like to me that you just from a standpoint of how it would, how it feels to have your system diluted in so many different algorithms. It would be good if you could have, it would make it more pure, to have a single that you give the user, and then you get the entire experience. But behind the hood, it's a super complex, right? A lot of algorithms, a lot of things to stitch together. And right, if one of them, like if the row thing, if someone messes that up, then the entire experience can, go really bad. So a lot of technical depth, I guess, is the. All right, together these algorithms make up the complete Netflix recommender system. So you have tons of recommender system algorithms like behind it. It would be interesting to know exactly how they look like. What are they doing? They mentioned, they're still using the 2009 one. The 2009 one was matrix factorization. So I mean, they must use something else as well, because they include the time of day that they watched it, and all of these extra information sources. That probably helps a lot, maybe. And to use that, I mean, it would be interesting to see how they look like. All right. They also have one for the evidence. They also decide which image out of several versions use best to support a given recommendation. I mean, it's insane. Like when you go to that level of commitment to personalization, where you have multiple different, like you have multiple different images for a movie, and you give a different person a different. I mean, it makes sense, but just that level of that level of detail, it's pretty interesting. Uh, all right, our recommender system is used on most screens of the Netflix product, and in total influences choice for about 80 hours streamed at Netflix. The remaining 20% comes from search. However, because members are also often searched for videos, uh, even search turns into a recommendation problem. Yeah, we looked at that. So when you search for this, you get some recommendations. Related work. Each of the algorithms relies on statistical and machine learning techniques. So we're probably not gonna get any details. Unfortunately, it seems like they're pretty anonymous here. Although we have the old paper, maybe that we can, that I read last time. This includes both supervised and regression and unsupervised approaches, dimensionality reduction through clustering or compression. All right. So then we have the matrix factorization. Yeah. All right. So the business value. Might want to skim this one, I think. Yeah, I'm not sure exactly. Yeah, like I mean, if the 80%, uh, yeah, it's difficult to quantify, right? Like how much of a business impact the the recommender system has, but the entire Netflix product is basically the recommender system. So like that's super valuable, I would assume. But sometimes I wonder too if you, as I said in the beginning, like if there are alternative ways of, instead of looking at revenue, that would still drive the product and become really good product. Like personally, I don't feel that Netflix. I don't know. A lot of people use Netflix a lot, but I don't, and it's because I don't find the recommendations to be that good actually. But on paper, if you look at statistics, right, they're the best recommender system for movies out there. All right, so improving our algorithms. Good businesses pay attention to what their customers have to say, but what customers ask for, and let's see. All right, so what customers ask for, as much choice as possible, comprehensive search and navigation tools, and more, and what actually works. A few compelling choices simply presented are very different. Using our own intuition, even collective intuition, to choose the best variant of a recommendation algorithm also often yields the wrong answer and is frequently simply impossible, particularly when trying to tell good from great recommendations apart. Um, all right, so you have a lot of like intuition failures where some intuitive things turn out to be better, I guess. Um, let's see, it shows the highest ranking PVR videos in the catalog from one of the authors, and even that author has no intuition based on these rankings about which offers best choices for him. Assessing the ranking for other people is even harder. So how do we know when an algorithm variant is better or worse? So they choose metrics for A/B testing. This is interesting. So our subscription business model suggests a framework to find the answer. Because our revenue comes exclusively from the monthly subscription fee that our current members pay, and we make it very simple to cancel at any time, we think that maximizing revenue through product changes is fairly equivalent to maximizing the value that our members derive from our service. Honestly, that seems fair, right? Revenue is proportional to the number of members. Let me check. Revenue is proportional to the number. Something happened to my stream, I think. All right. All right. So I think that seems to make sense. I don't know if there are any intuition errors on that, like if revenue is proportional to the value, but I would say it makes sense. So if we create a more compelling service but offering better personalized recommendations, we induce members that were on the fence to stay longer and improve retention. In addition, all members with an improved experience may be more enthusiastic when describing Netflix to their friends, strongly influencing new subscriber acquisition through word of mouth effects. Yeah. All right, changes to the product directly impact only current members. Thus, the main measurable target of changes to a recommendation is improved member retention. So I guess like here is the problem, right? Maybe. Or, okay, I don't know what they mean by retention. Let's see. That said, our retention rates are already high enough that it takes a very meaningful improvement to make a retention difference. All right, so they can't even measure all right. However, we have observed that improving engagement, the time that our members spend viewing Netflix, is strongly correlated with improving retention. All right, so this is like a worrying thing for me, right? So like they start with saying that, all right, they start with saying the revenue we make as a company is probably correlated to the amount of value that we bring to the world, which seems true. But they distill it down to say that like the what our driving force is to increase watch time. And I don't know if increasing watch time is the best movie recommender system. Think there's some like intuition that could be wrong there. But anyways, so they do that with A/B tests. Yeah, I guess we can. I don't have that much time to go through this now. All right, so they basically check, are members finding the part of the product that was changed relative to the control more useful? For example, are they finding more videos to watch from the videos than in the control group? So with the A/B testing, are members in a test cell streaming more on Netflix than in the control? For example, is the medium or other percentile of hours streamed per member for the duration of the test higher in a test cell than in the control? Are members in a test cell retaining their Netflix subscription more than members in the control? When a test cell is clear improvement. Yeah, okay. So they design A/B tests to measure it, and measurable retention delta. Yeah, okay. So it's very hard to measure this depending on the subscription per cell and the cumulative retention. All right, test cells for statistical validity. All right, so yeah, they check, I guess, with some type of hypothesis testing, maybe to see if they are statistically significant, depending on the sample size. A/B test results are our most important source of information for making product decisions. Most times our tests are extremely informative, yet despite the statistical sophistication that goes into the design and analysis, interpreting A/B tests remains partly art. Okay. For example, we sometimes see retention wins that pass statistical tests, but are not supported by increases in overall or local engagement metrics. In such cases, we tend to assume a random variation not driven by our test experiences. Our common practice is to then rerun such A/B test. Okay, that's interesting. Other times we see overall engagement increases without local metric increases. We're similarly skeptical of those and often repeat them as well, finding that the positive results do not repeat. So even with A/B tests, it's like difficult, I guess, to see. Interesting. Alternative metrics. There are many other possible metrics that we could use, such as time to first play, sessions without a play, days with a play, number of abandoned plays, and more. Each of these changes perhaps quite sensitively with variations in algorithms, but we're unable to judge which changes are for the better. I mean, it's a difficult problem, right? What they're trying to solve is really difficult. That doesn't seem like there's a clear how. I mean, like, yeah, I think their proposition of how they do things makes sense, right? If you actually boil it down, like, what metrics are you supposed to actually improve? I think this is the issue for YouTube recommender system as well, where people feel that it's not the best, or let's say the extreme case, like TikTok. Like TikTok has an incredible recommender system, but is it like giving most benefit to the people watching it, and like increasing happiness? Probably not, right? Alternative metric, yeah. So test audience. Typically test algorithms on two groups. The advantage on testing on existing is that the sample size can be larger because we have many of them, but existing members have experienced a different version of the product in the past. Suddenly changing their experience to reflect that of a test cell can yield behaviors that are influenced by their previous experience. I mean, this is such like interesting biases you have, right? What a complex problem to solve. It's actually really complex when you think about it. So many different layers. Uh, Pranav asks, what's your view about Andrei Karpathy? I mean, he is amazing, right? He's like, I mean, he is like the main person I look up to, I would say, when it comes to just his perspective on things, and his driving force of trying to help people, his just yeah, just generally his ambition, and yeah, I just think he's a great guy. Automatic or mixed precision helps in speed the training, and if yes, how much? Yeah, it does help 100%. Like, it does help. I don't know, it depends on the, like, the It depends on a lot of factors, but maybe like I actually don't want to give a number on that, but yeah, it helps a lot. It also helps with the VRAM, right? You basically have the VRAM usage. You can increase the batch size because as a result of that and so on. So you can, in many cases, have a larger model that you wouldn't be able to have otherwise. So yeah, it's really good. Ginoi Dragos asks, do you think transformers will take over CNNs in object detection vision tasks in general? Well, I mean, it seems like it already has, no? Like transformers. Well, it seems like CNNs are still really strong, but a lot of people use transformers for those tasks even now, is my understanding. So it seems like transformers have taken over most tasks. Decreased precision. From my understanding, mixed precision does not decrease the actual performance, and so yeah, I don't think. I think there have been papers I've read that have shown that it doesn't. I think mixed precision is standard to use. Yeah, like everybody does that. I think maybe for some applications, like you need maybe there are some sensitive applications where you actually like really need that precision with the neural network, but in many cases you're just doing approximations anyways, right? So like cutting it off, you can call that regularization, and you're good to go. All right, so they talk like it's such a complex problem, like even like not being able to test existing members because they see all these biases in that. But yeah, you can do faster innovation through offline experience. Like to me, having fast iteration time is like the most essential key in everything, like to do things quickly. Things can take a really long time, and just trying to do things through offline experience seems like the best thing if it's possible. All right, so I would like to go into this in more depth, but I need to skim it, I think, because I really want to finish this now. Let's see. All right, so you can, let's see. Offline experimentation changes from algorithm to algorithm, but always consistent computing a metric for every algorithm variant. Um, so I'm curious what is the actual metric that they use? That's what I want to know. As appealing as offline experiments are, because they're fast iteration, they have major drawback. They assume that members would have behaved the same way. For example, playing the same videos if the new value being evaluated had been used to generate the recommendations. Yeah, okay. Thus, for instance, a new algorithm that results in very different recommendations from the production is unlikely to uh, find that its recommendations have been played more than the corresponding recommendations from the production algorithm. So this is an interesting bias as well. So what is it? If the new algorithm being evaluated had been used to generate recommendations, thus, for instance, a new algorithm that results in very different recommendations from the production algorithm is unlikely to find that its recommendations have been played more than the corresponding recommendations from the production algorithm that actually served the recommendation to a member. This suggests that offline experiments need to be interpreted in the context of how different the algorithms being tested are from the production algorithm. Okay. Yeah, I mean, like it is a fundamental problem, right? I wonder how one actually solves that. I mean, that's like A/B testing, but okay, so they don't find them to be as highly predictive A/B test outcomes as we would like. That's really unfortunate. Like these recommender systems are really complex. Just like I mean, every machine learning problem is makes for complexity, but yeah. All right, and then you have more word of mouth effects. I'm gonna have to skim this, sorry. But yeah, like this is difficult to tell too. Like, how do you take into considering the word of mouth effects? Like that doesn't, the recommender system doesn't have that, right? But if it had access to that information, could have done a better job with the recommendations probably. All right, so key open problems, better experimentation protocols. Like how do we do this? I don't know if this has been done a lot of work on. I know, a lot of people use like NDCG, but stuff like that. But I mean, these are old. I don't know if there's any new types of offline experimentation metrics that people use. So I think this is just a fundamental problem, I think. Global algorithms. Yeah, so this is interesting too. Like they oh wow, I wonder if they have different algorithms for like different countries as well. That would be pretty insane. Probably not, right? They can't have that many algorithms. That would be mind blowing. Yeah, okay. So then the presentation bias, right? The ones that they show, a lot of people will see them, so they will have high engagement. Okay. Yeah, okay. There's a lot of interesting things to go through. I won't have time because I need to close the I have something in a bit. All right, but this was interesting to get an insight. I think mostly the interesting thing was just like how complex it is. It's just insanely complex, and you get a feeling that it's over engineered, but at the same time, you can't argue that everything they're doing, they're validating with rigorous testing, making sure that what they're doing makes sense, and yeah, it's just, I don't know, just interesting. All right, I'll probably continue on this. I'll probably make a video on this in the future, more polished. Now it's just me going through it, And Pranav asks, what are your thoughts about AI consultancy in the future? I believe, like, generally in uh, hmm. So first of all, I believe AI will have like it's starting to increase in the effects that it has, and I think it will continue to do so. Is my guess, and there will be search for people to do really interesting work, and so consultancy, and that will probably increase over time. But yeah, who knows? All right, guys, I'll pause the stream here. I know it was like a quick stream. I'm just trying to get back to just like not making streams into that major of a thing. Just hey, I'm checking this paper now, and hopefully like with time, I'll converge to something maybe. But now I'm just trying things out. All right, if there's no more like questions or anything, thanks for joining, and yeah, whatever time it is for you, hope you have a good day and or good night, depending on where you are. All right, see you next time, guys. Bye.